Okay, so now what we're going to do is we're going to look at what this pH scale really means. What do these numbers really mean? So when we have an acid or an alkali, we must remember that they are compounds that are dissolved in water. So for example, hydrochloric acid, HCl, is actually hydrogen chloride, which has been dissolved in water. And when they dissolve in water, they dissociate to form H+ ions and whatever the negative ion is, depending on what the acid is. Okay, so we've got hydrogen ions, and chloride ions, and this has been dissolved in water. So acids and alkalis are solutions. pH, they think, stands for the power of hydrogen. And this scale is a measure of the amount of hydrogen ions that there are in any solution. So if something has a low pH, it has a very high hydrogen ion concentration. And conversely, if something has a very low pH, a very high pH, an alkali, it has a very low H+ concentration. And we go from high concentration to low concentration as we move up this scale. Now, we imagine here that we've got hydrochloric acid, and we've got it as a concentration of 0.1 moles per decimeter cubed. Okay, this means that in 1 decimeter cubed of water, we have 0.1 moles of hydrogen chloride that has been dissolved in it. If I want to change my pH to pH 2, I want to increase the pH, make it slightly less acidic. What I need to do is I actually need to dilute that solution by a factor of 10. So my concentration at this point will be 0.01 moles per decimeter cubed. And it follows that if I then want to make something that has a pH of 3, I need to dilute it by another factor of 10, and my concentration here would be 0.001 moles per decimeter cubed. And so that continues. So another way of writing this is my concentration is 1 times 10 to the minus 1. Here my concentration is 1 times 10 to the minus 2. Here my concentration is 1 times 10 to the minus 3. And you can see that this number here corresponds to the pH. Okay, the power of hydrogen. So what's important is that one unit change in pH is a 10-factor change in the concentration of hydrogen ions. So if I want to make it less acidic, I need to dilute it by a factor of 10 each time. So if I change from pH 1 to pH 3, I need to actually dilute it by a factor of 100, 10 times 10, to get to here. And that continues all the way up. Okay, and this is called a logarithmic scale. So the most important information you need to know is that pH scale is a measure of hydrogen concentration, hydrogen ion concentration. High hydrogen ion concentrations when you're an acid, and every 1 unit change in pH corresponds to a 10 times change in dilution of that solution.